Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
You might have recently watched my video on right triangles and you might have learned all about SOHCAHTOA. Unfortunately, there's some limitations to SOHCAHTOA, and that is you have to have a right triangle. When it comes to the law of sines is going to be how we solve for missing pieces of any triangle. So again, it works for any triangle. Okay, now it's important to make sure that we understand how the letters of the triangle work. So I'm going to go ahead and draw two triangles. One, I'm going to use traditional lettering that you might see in your geometry book, and in another, I'm going to do lettering like you might see in a trigonometry book. Okay, so sides are labeled with lowercase letters, so A, B, C, and that's in both. The difference comes in labeling the vertices or the angles. So in your geometry book, here's A, so you're going to see A. Here's B, so you're going to see B. Here's C, you're going to see capital C. And I know it's hard to differentiate between lowercase c and capital C. However, in trig, they're going to label the angles. So here's A. So here's alpha. Here's B. So here's beta. And here's C. So here's gamma. And my gammas are very, very not correct. I know that. I think they look like wishbones actually whenever you look at it, but I've just kind of done my best to make it not look like a Y as well, since my gammas are not the strongest. So ABC, alpha, beta, gamma, or lowercase ABC, capital ABC, okay? If this is the smallest side, this is the smallest angle. If it's the biggest side, it's the biggest angle. They have to go together like that. So what we're gonna see here is we're going to maybe be given, I'm just going to give you the information. We'll draw the triangle. And I'm going to do it using geometry letters right now, because I'm assuming most of you are probably in geometry watching this video. So angle C is 81 degrees. Angle B is 42 degrees. Okay, now I will, before we go any further, I like to have my students try to find this acute angles first. Here's why. If I do the sine of 150 degrees and I do the sine of 30 degrees, they're the same thing. So if my angle is supposed to be obtuse and I say, okay, well, what's the angle? It's going to tell me 30 degrees. It's not going to tell me the 150 degrees. So for that reason, you're always guaranteed two acute triangles. So I would try, emphasis on the word try to find the acute angles first. And the thing is if you have your two acute angles, you have your third angle. And based off the size of your acute angles, it's going to either have to be obtuse or acute. In our case, we have two angles already. Oh, and I forgot to give you the last piece of information because I got distracted by that. There we go. So I could have drawn the triangle. Instead, I put it in a chart form. And so here's what we're going to do is we have to find the missing pieces. This is obviously not a right triangle. We can double check that by going 180 minus 42 minus 81. Sure enough, that third angle must be 57 because our three angles have to add to 180. So none of those are 90, so we can't use SOHCAHTOA. What are we going to do? Well, that's what's going to happen when we need the law of sines. So the law of sines is super easy to memorize. I encourage you to have it memorized. You do not have to have it actually memorized for the ACT. It actually is generally put in there for you. So it's just a ratio between the angle and its corresponding side. So sine of A over A, taught trig a lot, I almost said alpha. Sine of B or beta over B sine of C, or gamma over C. That's it. That's all there is to the rule. So let's say we're looking at A. Well, let's go ahead and we're going to fill in just our known parts. So sine, we know the angle. Sine, we know the angle, and we know the side. And sine, we know the angle. So as you notice, we have two missing spots. We're missing A, and we're missing C. So what's going to happen here is that middle part has a perfect numerator and denominator, as in we know both. So that's going to be our key to finding all of our missing information. So I'm just going to cover this up. What we see now is we see a fraction equals a fraction. And in Algebra 1, we learned that we can do cross products. So the cross products there would be 9 multiplied by the sine of 57 degrees is going to equal A times the sine of 42 degrees. And to get rid of multiplying by the sine of 42 degrees, all we have to do is divide it to the other side. So you're going to take your handy dandy calculator. And we're going to find out, well, my calculator did that. Let me make it a decimal. It's 11.28. Okay, so that was for A, 11.28. Well, 42 is smaller than 57, so yes, our smallest angle is still, and our smallest side still correspond, so we're good. That's fine. Now, see how 81 degrees is our biggest angle? We're going to expect C to be our biggest side. How are we going to do that? Well, we're going to repeat the process. C is going to be multiplied by the sine of 42 degrees. And that will equal 9 times the sine of 81 degrees. And then we'll just divide. So if you have the rule, all we're going to be doing is substituting cross products, substituting cross products, substituting cross products. That's our whole goal. Okay, so we have 9 sine of 81 divided by sine of 42. Notice I'm closing my parentheses here. 13.28. And I really should have a squiggle equal sign on those to mean approximately, because I did round. That way we keep it straight on which ones we rounded and when we didn't. So anytime you have a non-right triangle, the law of sines is going to be your friend. So let's try that from a picture form. Okay. Okay, so let's solve the triangle. There's no letters on here, so what letters do we want to use? We can use J, K, and L for the heck of it. Okay, so sine of L over 2 equals sine of K over 4 equals sine of J over J. Well, that last part is really not helping us at all. And fortunately for us, I said solve for our acute angles first. Well, 70 is definitely an acute angle. And Since 2 is smaller than 4, L has to be smaller than 70. So that's our second acute angle. So J could be our middle angle or it could be our biggest angle. It depends on how tiny L is. So cover that up. First step, cross products. 4 sine of L, 2. And sometimes I use cursive for my sine, cosine, tangent, just so I remember they're all one thing. They're a button on the calculator. Okay, so to get rid of multiplying by 4, I'm going to divide by 4 to both sides. That will leave me with sine of L, not just L, but sine of L. 2 sine of 70, close your parentheses, divided by 4. 0.4698. If you recall, to get rid of the word sine, I have to use inverse sine to go backwards and find my angle. Using at least 4 decimal places ensures that we don't make an error of rounding. And I'm going to show you the difference between using 4 decimal places and using a lot of decimal places. Well, also helps if I don't put in an extra 0. 0 point, not 0.0, right? So both of them are saying 28 degrees. So I think it's safe to say even with 4 decimal places, it did get a smidge off later on, but it does definitely look like 28 degrees. And most of the time your book is going to allow you to round, if not to the nearest angle degree, to the nearest tenth of a degree. So 28 is pretty safe for both of those. So we just found out angle L is 28 degrees. So how could we find angle J? Well, they have to add to 360. So we've got 20, or not 360, 180. Boy, I need my coffee this morning. So we're sitting at adding to 98 right now. So we need to make sure that the other angle is 82 degrees. Now that we know it's 82 degrees, we could, if we wanted to, go ahead and repeat the process for sine of 82 equals J times the sine of 70, and we'll divide by the sine of 70. Since this is our smallest angle, or no, it's not, it's our biggest angle. It should be our biggest side. I was looking at the wrong angle for a second. So we have 4 sine of 82, divide that by the sine of 70, and we wind up with 4.22. So J is approximately 4.22. So the first step I always go to is the law of sines. Anytime I have a non-right triangle, will it work on a right triangle? Absolutely. Definitely it will. Let me just go ahead and show you why it works on a right triangle. Because I know some people are like, yeah, but why don't I just use SOHCAHTOA? You could. So let's say you're trying to do sine of 30 degrees. And here's your 30. Opposite, adjacent, adjacent, hypotenuse. Okay, so sine of 30 would go with the opposite. Sine of 90 would go with the hypotenuse. Okay, well, sine of 90 is just 1. So this really is just 1 right there. So when I multiply the word the opposite to the other side, we'd have sine of 30 equals 1 over hypotenuse multiplied by the opposite, which is the same as the opposite over the hypotenuse. So you can do law of sines with a 30, 60, 90 triangle or with any 90-degree triangle. You can also do SOHCAHTOA. If it's not a right triangle, you have to do law of sines. Okay? So if it's a right triangle, you can do SOHCAHTOA or law of sines. If it's a non-right, you need law of sines. So keep that in mind. Right triangles, you get choices. Non-right, got to go to the law of sines.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.